Page 423, example 3. Compare proportional relationships represented by graphs and verbal descriptions. So you can see we have a graph over here of the price of granola cereal, and we have a word problem. The graph represents the cost per ounce of granola cereal. A 15-ounce box of raisin cereal costs $3.90. Which cereal costs more per ounce? There should be a space there. Use equivalent ratio to find the cost per ounce of the raisin cereal. So we were told it's $3.90 for 15-ounce box, and they want us to find the cost, so we're going to put that first, per ounce. So that's what we want to get down to 1. So cost over ounces, and we're going to divide each side by 15, and we're going to get that, let's see if they rounded this, $3.90 divided by, nope, comes out even, 26 cents per ounce. So that's our raisin cereal. Raisin cereal costs 26 cents per ounce. The granola cereal costs 25 cents per ounce. Well, how do we know this? By looking at our graph. Again, you can see here's the weight. This is our x-axis. A pound is a pound, or the weight in ounces is an ounce is an ounce. It's pretty clearly defined. This is our independent variable, but the cost is going to depend on this. So this is our dependent variable, and this is our y-axis. So we don't have 1 ounce marked here. We could maybe eyeball it and try and figure it out, but in mathematics, when we have data that we can use, we want to use that. Notice that they gave us particular points because this line does not have points where the blue lines are intersecting. So in this case, we're relying upon the publisher who gave us the points. And this is x1 and y1, and this is x2 and y2. So you can see when I subtract my y values, I'm finding the difference again. 5 minus 2.5 is 2.5. So 2.5 is the y, we call it the rise, going up and down. And 20 minus 10, those are my x values, and I'm subtracting, and I get 10. So going over 10 and up 2.5. So they took 5 minus 2.5 over 20 minus 10, and they got $2.50 over 10 ounces. And when they divide that down to 1 ounce, divide each of these by 10, they get that the cost per ounce is 25 cents for 1 ounce. So you can see that the raisin cereal costs more per ounce. Last one, try it. The distance covered by the fastest high-speed train in Japan traveling at a maximum speed is represented on the graph. The fastest high-speed train in the United States traveling at a maximum speed covers 600 kilometers in 2.5 hours. Which train has a greater maximum speed? Explain. So again, you can see this is Japan, and here's our x and here's our y. You can see that when we look at 1, it doesn't really line up again with the blue lines. Again, we could ballpark it, but that blue line or that blue dot is kind of large, so you're going to take it off the top part of the blue dot, the bottom, the middle. It looks like these are going by 200, so 300 is somewhere in here. And again, my line doesn't look like it lines up perfectly on the intersection points there. So that makes this one a little trickier, and you'll notice that they don't even give us any points on this one. So I'm going to start with what I know. I'm going to start first by looking at the United States train and figure out what its constant of proportionality is, because I can figure that out. So k is equal to y over x, which is equal to 600 divided by 2.5, which is equal to 240. This is kilometers. Yep, kilometers per 1 hour. So I know that my US, my unit rate for my US train is 240 kilometers per hour. According to the graph, the high-speed train in Japan travels more than, so if I look at 1 hour, I can see that the high-speed train travels between 200 and 400 kilometers per hour, and I'm not sure where it is here, but when I go to 2 hours, I can see that it's going to be over 600 miles, or 600 kilometers per hour. I'm not quite sure what that point is, but whoops. Here's my 2 hours, and it's over 600 kilometers. Well, if I know that my US train has a constant of proportionality of 240 kilometers in 1 hour, in 2 hours, the US train would be going it would travel 2 times 240, which would be equal to 480 kilometers in 2 hours. Well, 480, if this again is going to be about 500, 480 is going to be below what the Japanese, in 2 hours, the US train would travel 480 kilometers. So here's 2 hours, here's approximately 480 kilometers. I can see that that is less than what the Japanese train can travel. So even though I'm not given data points here, I can use the information that I am given about what I do know, the US train, and then I can look and I can analyze this graph and say, well, what data points over here can I use to compare to what I know? So which train has a greater maximum speed? The Japanese train. Has a greater maximum speed. Because it travels further in 2 hours.